The countdown had already begun long before Pluto filled the camera. 9.5 years after leaving Earth, New Horizons was still millions of kilometers from its destination, yet the mission was already running out of options. Inside the Johns Hopkins Applied Physics Laboratory, the final encounter sequence was steadily becoming permanent. Every passing day locked another decision into software that would soon be impossible to change. The spacecraft was heading toward the only close-range meeting with Pluto it would ever make. And once that sequence had been uploaded, no one on Earth could guide it through the most important hours of the mission. The journey itself had never been the hardest part. Launched in January 2006, New Horizons left Earth on the fastest departure trajectory ever achieved by a spacecraft. It crossed the Moon's orbit in hours instead of days, borrowed additional speed from Jupiter a year later, and continued outward for nearly 4.8 billion kilometers. That speed made it possible to reach Pluto within a human career. It also meant the spacecraft could never stop there. It carried nowhere near enough fuel to break into orbit. Everything scientists hoped to learn had to be gathered during a single high-speed pass. The incoming images quietly reflected that shrinking opportunity. At first, they revealed almost nothing, a tiny blurred disk separated from the background only through careful analysis. Weeks later, the bright region that would become known as Tombaugh Regio slowly emerged from the pixels. Each new frame confirmed that the spacecraft remained on its intended course. Each one also marked another day that could never be recovered if something went wrong. 10 days before closest approach, the signal vanished. Mission control screens froze on the same telemetry values. Radio contact with the spacecraft had been lost. There was no explosion, no dramatic warning across the displays, only silence. Everyone in the room understood what that silence meant. Pluto would not wait while engineers searched for answers. The cause emerged only after the first tense hours. While preparing the enormous command schedule required for the encounter, the spacecraft had overloaded its main computer. Its backup computer responded exactly as designed, placing the spacecraft into safe mode and suspending normal operations. The protection system had preserved the spacecraft, but it had also interrupted preparations for the one event the mission could not postpone. Across the Independence Day holiday, engineers settled into long shifts. Checklists replaced speculation. Commands were rewritten, verified, transmitted, and then followed by hours of waiting. Every exchange with the spacecraft required roughly 9 hours for a question to travel outward and an answer to return. A mistake could not be corrected immediately. The next decision often had to be made before the previous one had been confirmed. Gradually, normal operations returned. The primary systems resumed control. The science timeline was rebuilt. By July 7th, the complete encounter sequence had been loaded once again. The countdown continued, but the remaining time now felt much shorter. One digital file had become the most important object aboard the spacecraft. That command package contained thousands of precisely timed instructions compressed into roughly 9 hours of autonomous activity. Cameras, spectrometers, particle detectors, and radio experiments would activate one after another with almost no idle time between them. Every rotation of the spacecraft had been calculated years in advance. Every observation depended on reaching the correct orientation at exactly the right second. Then the high-gain antenna slowly turned away from Earth. Communication stopped by design. The spacecraft could not keep pointing home while its instruments studied Pluto. Without a movable camera platform, the entire vehicle had to rotate as a single body. During the most important observations, New Horizons intentionally abandoned continuous contact with Earth. For hours, no one knew whether it was operating normally or drifting silently through empty space. Inside the spacecraft, the sequence continued exactly as planned. Thrusters nudged the vehicle from one target to the next. The long-range camera fixed its gaze on Pluto's leading hemisphere. Light that had traveled for hours across the solar system finally reached the detector, and a bright, heart-shaped region spread across the sensor. What had once been a distant point of light now revealed mountains of water ice, vast plains of frozen nitrogen, and landscapes unlike anything scientists had expected before arrival. Observation time continued to disappear. Every second, New Horizons swept nearly 14 kilometers closer to the far side of its opportunity. Closest approach came within roughly 12,500 kilometers of Pluto's surface. There would be no second orbit, no chance to revisit a mist valley or repeat a blurred image. Every completed measurement entered permanent memory. Every missed observation was left behind forever. The encounter did not end at closest approach. New Horizons continued into carefully planned geometry, passing through the shadows of Pluto and its largest moon, so sunlight could shine through their thin atmospheres toward waiting instruments. Those measurements depended just as much on timing as the photographs. Missing the alignment by even a small margin would have erased an entire category of science from the mission. Back on Earth, there was nothing left to do but wait. The 70-meter antenna of NASA's Deep Space Network in Australia pointed toward the place in the sky where the spacecraft was expected to appear. Eventually, a faint carrier signal emerged exactly where predictions said it would. The spacecraft had survived. That single tone carried no photographs, no maps, and no discoveries. It confirmed only one thing: New Horizons was still alive after racing through the Pluto system. The real cargo returned far more slowly. Only a tiny stream of information, roughly 1,000 to 2,000 bits each second, flowed back across billions of kilometers. The spacecraft had recorded about 50 gigabits of scientific observations, but transmitting them demanded patience measured not in hours or weeks, but in seasons. Month after month, the Deep Space Network collected another fragment of the encounter. 15 months after the flyby, the final block of Pluto data reached Earth. By then, the blurred circle that had guided navigation had become a completed global mosaic. Tombaugh Regio no longer served as a target. It had become the permanent record of humanity's only close-range flyby of Pluto, preserved frame by frame as New Horizons continued deeper into the Kuiper Belt.